Okay, I thought we would talk about planetary image processing since Jupiter and Saturn are both well placed in the evening sky for observing and imaging. And these are fairly straightforward programs to use. Most of them are free, and so it makes it very easy to spend some time working on them. And unlike deep sky imaging, where you spend many, many hours collecting the data and then many, many hours processing the data, here the data collection usually is very quick, and the processing is relatively simple as well. So we're going to go through 4 different programs this evening: one for stacking the images, a couple for sharpening, one for derotating, and then possibly some final processing at the very end. So let me start. We're going to start with Auto Stacker 3. An Auto Stacker is one of the best programs for actually stacking the planetary images. So the image I'm going to use tonight is an image of Jupiter that I acquired about a month ago, and we'll kind of follow along with it all the way through the various stages. So this is what the fire capture software looks like when you open it. As you can see, it doesn't fill the entire screen. There's no real way to do that. But the 2 parts of it, there's a viewing part, and then there's the setup part, and they kind of work together, and you can arrange them however you'd like. So first of all, let me open the image.
So, Greg, we are only seeing the frame view panel.
I'm sorry?
We can only see the frame view panel, not the one with all the configuration settings.
Okay.
I mean, we do see the open dialog box right now.
Okay. I think when I open the image, you'll probably be able to see it. Hang on here. How about now?
We see, yes, we see the image.
Okay. So over on the left-hand side are some of the setup, and then the image is actually displayed over here in the box. A couple things to be aware of: the image can appear bigger. There may be some borders on the image that you see here in red. What you want to do is you want to reduce the borders down to just the image before you do the image analysis. If you don't, you're liable to get some funny numbers in there. So once you've done that with the image size sliders up here so that just the image is highlighted, then you're ready to go ahead and begin the process. There's 3 basic steps. We just did the open, which you see up here. Second is to analyze, and third is to stack. And stack, you can see, is grayed out at this time. So if we click analyze, before we click analyze, one thing to be aware of is that you can look at the various different frames in a couple different ways with a slider up here, or you can just hit the play button right above the image, and you'll see a video representation of the video files that have been collected. And you see them kind of going by here. This is relatively good data, and that's why I'm using it. But in any case, looking at the data visually many times can help you decide how many files you want to stack. You can also increase the brightness of the image with the little up and down icons right here where it says brightness. And sometimes that's useful because if you increase the brightness, you'll notice the planet is pretty much blown out, but you'll notice that the planet Europa is faintly visible up here in the corner. And so if you're not sure if you've got one of the moons in the field of view, sometimes increasing the brightness can let you find that moon. So the first thing you normally want to do is analyze the image. And you want to do that with the planet selected up here, rather than surface. Surface is for things like the surface of the moon or the sun, but typically for planets, you want to have the planet checked. The rest of the stuff over here, you can pretty much leave as the default. And then you click Analyze, and the program goes through the individual frames in the AVI and gives you kind of a graph of what the data looks like. Down at the very bottom, you probably can't read it on my screen, but down here it says that there were 2,647 frames. This was a 30-second AVI collected at about 90 frames per second, so should have been about 2,700 frames. Turned out as 2,647, and so what we're seeing here is the best frame picked out of those. That's the one that it's decided it should use for a reference. The thing that's
Greg,
yeah.
Greg, we're not seeing the left panel where those controls are.
You're not.
No,
Oh.
we're only seeing the right larger panel. We're not seeing the left panel.
Okay, let me see if I can.
Did you share your whole screen or just a window?
Just the window, I believe.
See if you can share your whole screen.
Yeah, do a whole screen.
How about now?
And
Now
then,
we've
now
got-
we're seeing the dialogue with quality graph and the open
Okay,
button
and the
all that
picture.
No, now we
You
only
may-
have the left panel.
Greg, you may have to unshare and then reshare again, but select the
Like the-
monitor which has the whole thing on it.
Okay, let me try that. Okay, what do you see now?
Just the left panel.
Just the left panel, okay.
If you can toggle back and forth between the panels, there you go.
Now
Now we're
we've got
seeing
the
the
right
right
panel only.
Yeah, it looks like it's not, even though I bring up a new share, it's not letting me share both of them at the same time. Okay, let me share the left panel. Okay, I'm presuming you can see the left panel now.
Yes.
Okay, the quality graph is probably the most confusing part of this. And that's because it draws this 50% line and it puts that across the panel, which shows all of the data. So if you keep in mind, if the 50% line crosses the 50% enumeration of the files that are accumulated, about here is about the best you're going to get. So anytime this line crosses before you get to the center line here, you probably have quite a good quality set of data. If it only crosses way back here, then you may have lesser quality data. But what I found is the real key is to look at the images themselves, which you can't see right now, but to look at those panels in order to just make a decision as to how many frames you wish to stack. And this data looked pretty good to me. And so if it looks really good, I usually stack about 75% of the available frames. So you can see up here at the top, you can either select a number of frames or a percentage of frames to stack. And I've typed in 75 here, and that's going to take the 75 best frames and stack those for you. One thing to be aware of, there's an option button right down here. And if you click on the option button, it brings up another dialog. One of the things that this dialog allows you to do is check a box that says open in Registax. And normally in the past, I've been using Registax for sharpening. And so it's nice to have that box checked. You don't need to worry about anything else in that box. But when the stacking process is done, AutoStacker will automatically load that image into Registax so that you can apply wavelets to it. We're not going to do that tonight. We're going to use a slightly different program, but I emailed the author of the program last week when AutoStacker 4, the beta version, was released, and asked if they were going to have the similar function to load the file automatically into another sharpening program called Wave Sharp. And he said he hadn't thought of that, but it was a good idea. So that may be something that will come along in the future. The other thing that you can do here is you can implement drizzle either at 1.5 or 3. I've used those a few times, but most of the time they're not really necessary. You can try that if you have really good quality data and you want to make it slightly larger. When you're ready to stack the images, you have to go to the viewing, pick the other panel. So let me do that. And you go to this panel and you have to place a grid. And there's various different grid sizes here. I've got 48 selected, and you click place grid, and you see that the program automatically draws these alignment points on the surface of the planet for you. What you're looking for is about 100 or so alignment points. Now, in this case, we ended up with 153 alignment points, which is maybe overkill. And you can adjust these numbers up and down with the little buttons here. But typically for Jupiter, I usually use 48. For Saturn, which is a smaller disk, I might use 24. Once you've selected the alignment points, if you want to use those alignment points, you're ready to go. If you decide, oh, I don't like those, you can hit clear and it clears them. You can go back and put them in manually if you want. But in any case, usually just selecting place the alignment points and letting it do that will give you everything you need. So we've got about 153 alignment points here. At this point, I'm going to go back to the other frame so that you can see it. And I'm going to select the stack button. So when I click stack, the program begins stacking the images, and there's a little countdown clock here that shows you how rapidly it's proceeding. One of the things that I should mention as well is I usually stack the first image to see how it looks. And if it looks good, then I can go back and select all of the other AVIs that I've collected in that particular session. Now, for this session tonight, I'm going to just use 3 AVIs, and I've already stacked the other 2. But AutoStacker has a nice function built in that allows you to select multiple AVIs, and it will apply the same settings that you've decided on here, the same alignment points to each one of those AVIs. So it's kind of a batch process, and it speeds things up tremendously. So if we go back to the other frame, you'll see once the stacking is done, the alignment points pop back up, and you're ready to go on to the next step. Any questions? I know it's difficult to read some of what's going on the screen here. So if you have any questions. All right, let me go. Yes.
My experience in the past, my planetary images are much smaller than that. Did you make that larger, or is it actually native to your optical train?
That's the data from my optical train. You can use AutoStacker on much smaller images. You would just reduce the size of the alignment points so that you get a bunch of alignment points on the image. Like I said, for Saturn, I might pick the 24 or even lower this down to 16, looking to get somewhere from 80 to 100 alignment points. On a very small image, you might not get that many.
What focal length are you working with there?
This is about 6,000 millimeters.
Oh, geez. Okay.
The C11 with a 2x Barlow. So
okay.
a little over two times the native focal length.
No
Okay,
wonder. Thank you.
all right. Yeah, I should have mentioned that. This is Jupiter close to opposition with a really long focal length. So I'm going to not go to Registax, or let me go to Registax. Can everybody see Registax now?
Not yet.
Okay. How about now?
There you go.
Okay. So Registax was introduced way back, I don't know, 2011 or something like that. And originally, this is what we used to stack the images and then to sharpen them. In recent times, the last 2 or 3 years, AutoStacker has been the go-to program for stacking. And Registax was used just to apply these wavelets. And the wavelets are very useful to apply. You can find a combination of wavelets that works very well for you and apply it, as well as do some histogram adjustments in Registax. And again, AutoStacker would automatically load the image in, as you see here. But a newer program has come along that's written by the same guy that wrote Registax, Cor Borvet, and it's called WaveStack. And so I'm going to pull it up because it does everything that the wavelets function in Registack does, and it does it slightly better. Now, let me see if I can find it. Okay, do you see waves?
Not yet.
Not yet. Hold on. I seem to have lost it. Hang on. I'm going to close this because we're done with that and start over. Okay. This is Wave Sharp. Everybody see that?
Yep.
Okay. And I'm going to load in the file that we were just working with. And here it is. Can everybody see that?
Yep.
Okay. So WaveStack has basically 3 controls here that you see on the right-hand side, and each one of those are wavelet controls. So they've reduced the number of wavelet adjustment controls from 6 down to 3, and they work similar to the way they worked in Registax. If you've used wavelet sharpening before, you realize that you set a sharpening number, and then you can adjust how much of that sharpening gets applied. Before we do that, however, there are some controls down the middle here that I'm going to share with you. The first one is the open file, which we've already done. The second one is to save those files, and then there's a settings. The one that is probably the most useful is, let me blow this up. Can everyone still see that?
Yep.
Okay. There's a histogram file that you can bring up. And again, this is where you can do some of the adjustments that you need to do along with sharpening. One of the adjustments is to auto balance the color, and that's done simply by hitting the auto balance button up at the top here. and you can see that it adjusts to the three curves here. The auto shift helps make it a little bit better as well. And then there's a couple of buttons that you can hit to reset those things if you don't like the results that you've got. You can save the settings that you generate here in a couple of different locations so that you don't have to go and do this each time. Once you find a group of settings that works well for your image, then it's easy to just call up that preset and it will automatically bring that up. This is looking at the log form of the graph. If we change to the regular linear form, it looks like this. And this slider down here at the bottom is the main brightness slider. And that's the one that you can bring over to where you want it to be in order to get the image to be as bright as you'd like it to be. So you can see here now we've brightened the image significantly, and we're ready to go ahead and do some sharpening. So in order to do the sharpening, and let me move this out of the way. In order to do the sharpening, you're going to adjust the various different sharpening numbers here. And I've already created several presets, and I'm going to load one that's called Jupiter and reload that. And that automatically pulls up the settings on the three wavelet controls here in order to show us what we're going to achieve with the planet. So can everybody see that?
Yeah.
Okay.
Yes, I noticed that there's is that a moon in the upper left hand?
Yes, that's Europa.
Okay, so that can be edited out later in Photoshop or whatever, because it's,
Why would
looks
you
a
edit
little
that
bit-
out?
well, it's not round. I'm a perfectionist.
Yeah, well, you can adjust that, manually go back and clean up some of the aberration that's around it, because these programs don't perfectly align the moons. Although when we get to WinJupos, you'll see that it does a pretty good job, because we're not going to work with just this single image. We're going to actually use multiple images.
Okay,
And it takes into account not only the rotation of the planet, but the movement of the moons as well.
okay. So what I see you're doing here is you're going to make Jupiter look like it does to the human eye when there's perfect seeing.
Well, that's what we're attempting to do, yes.
Right, I understand.
Okay.
Thank you.
So some of the settings to be aware of over here, there's a couple of different types of filters. There's the Gaussian filter. You can see when I click it, the sharpness kind of is not quite as good as using zero Gauss. I have no idea what zero Gauss actually refers to, but it tends to do a better job of sharpening, at least to my eye, than the alternative. You'll also notice over on the far right-hand side, there's some denoise settings. The denoise settings are very useful because when you sharpen, you tend to also introduce noise. One of the things that's nice, that's very helpful in WaveSharp is the magnifier. So when you pull up the magnifier window, you can pick a particular spot, let's say the great red spot here, and magnify it, in this case, by a factor of 2. And then when you adjust your sliders for wavelets, you can see how much noise you're actually creating. So if I turn off the noise, the denoise for this particular slider here, you can see that the planet itself is a lot noisier. If I turn this back on, you can, well, you may not be able to see it. If I turn it off and move the slider way up, you can see that you can create a lot of noise. And so you want to adjust the slider so that you get adequate sharpening, but with not a lot of noise. So if I bring it back to around 30, as I've done here, you can see there's some sharpening going on, but there's still a lot of noise. By turning on the denoise and adjusting these numbers up or down with the buttons, you can eliminate most or all of that noise. So again, what you're doing here is a balance between the wavelet sharpening and the denoising in that particular wavelet group. And so typically you adjust these by eyeballing what's going on at the planet and using denoise and the wavelet sharpening to achieve the amount of sharpening that you're interested in. I think that's pretty much everything that we needed to cover here.
Hey, Greg,
Yes.
what's the difference between the slider, which sharpens, and the digital box in the upper left, which seems also to increase sharpening?
Well, the digital box in the upper left is actually the wavelet number, the way I understand it. And the slider down here is a percentage as to how aggressive you want that particular wavelet to be applied. They
Thank you.
don't have a lot of, there are a couple of videos on Wave Sharp, and I'll give you the link. There's a article by Sean Walker in the November issue of Sky and Telescope, if you're a subscriber to that, and I'll give you the reference to that at the end as well. But it's my understanding that if I turn this all the way down, even though this is at 2.70, it doesn't make any difference turning it on and off. You have to adjust the slider up to where you want it once you've picked a value here. So again, you balance this value along with where you adjust the slider. Again,
Question,
yeah.
can you type in the values instead of using the slider?
I believe you can.
Okay, thank you.
Yeah, I believe you can. At least you could in Registax. I'm not sure if you can here. Let me try. Yes, you can.
Excellent.
Okay. Once you've got the image looking the way you want it, then you have to save it. And so you go up here and you save it, and you see, you probably can't see, but it's added the suffix WS to my image here. And I'm going to put X75 at the end just so I realize that this has been sharpened, and this is a stack of 75 images. So we've saved the image. I've already saved a couple of other ones. So now we're ready to go to the third step, and that is to go to WinJuPost, which is going to derotate and stack the various images that we've created. Any questions on Wave Sharp before we go? Okay.
So you've done a number of videos that you're going to now stack the process image
Yes.
of.
Yes.
You limit those videos to a certain duration, I'm assuming because you don't want to have over rotation on each video.
That's correct. I limited the videos here to about 30 seconds. And again, that's because Jupiter's rotating rapidly. The moons are moving pretty quickly. And at the focal length that I'm shooting, a minute or 2 minutes would probably would cause too much smearing of the actual image. So I take 30-second images, 30-second AVIs, and then stack several of those.
I have a comment.
Yes.
So far, I believe you've used 4 separate programs to do this job. Is that correct?
Yes. Actually,
Okay.
5.
5?
Well, Registax or Wave Sharp, one or the other of those, yeah. You can use either one to do the sharpening that we've just done. But I think Wave Sharp is a little simpler to use, and it was just released about a year ago. And so it's pretty much supplanted Registax in terms of just doing the wavelet sharpening. It doesn't do any of the other stuff that Registax used to do. Okay, you should be able to see now WinJuPost, which is basically just a gray screen. Does everybody see that?
Yep.
Okay, first thing up at the menu at the top is Program. And under Program, you have to pick the celestial body that you're working on. So you can see here, it does all the different celestial bodies in the solar system, but we want Jupiter and it's selected. So it knows that we want to work with Jupiter. WinJupos does a lot of different stuff, but mainly it's done to derotate images of Jupiter and other planets as well. So once we've selected that, we go to the next menu item, and that's recording. And at the very bottom here, image measurement. We want to measure these images of Jupiter. So I've already loaded in the image of Jupiter. You see it here. Typically, when you load the image in, you're probably going to see something that looks like this. I'm going to the adjustment tab, the second one over. You're probably going to see something that looks like this. In other words, the outline here in WinJupos may not match what you have in the from your image. It may be rotated one way or the other, and it may not match. But the developers of this program were pretty clever. They selected the F11 key to automatically try to match up Jupiter to the way it should be for the time and date that you imaged it. I didn't mention, but back in AutoStacker saved the image using the format that WinJupos requires in order to extract the date and time of the image from the image title. And you can see that way down at the bottom here. In any case, once WinJupos knows when this image was supposedly taken, it will try to match the outline of Jupiter, as you see here, to the image. And so when I press the F11 key, it does that. Now, if it doesn't match it perfectly, you can adjust the rotation or the size. The page up and down keys, page up and page down, will cause it to increase or decrease the size of the outline. The P and N keys will cause the outline to rotate, and you want to try to get it as close to the correct orientation to Jupiter as possible. In other words, you want N to be over the North Pole, and you want P to be over the equator. And ideally, you would like any of the moons that are available to be highlighted as well. And you can see here, this is where it thinks Europa should be when Europa is really here. Again, if I hit F11, it pretty much pulls everything to where you want it. The bad news is it doesn't do this for the other planets. The other planets, such as Saturn, Mars, Neptune, you have to do these things manually. But for Jupiter, you can hit the F11 key, and it will automatically bring everything into where it thinks it should be. You can still make final adjustments. There's a bunch of, yes, question?
Say like you're doing Saturn.
Yes.
So you're saying it will not automatically select multiple moons?
Yes.
Now, will it select multiple moons in a Jupiter image?
It will if the moons are in the image.
Okay, so say like Titan is close to Saturn, along with Iapetus or whatever. It cannot select more than one moon?
No, it'll select all of them. In other words, this is zoomed one. If I zoom out, you'll see here's another one over here.
Oh, okay.
Okay.
So it will select them.
It'll select all the moons. In fact, let me just show you under tools. We're going to come to tools here in a second, but under tools, there's ephemerides. And if you put in the date and time of your observation, it'll show you exactly what's visible there. And you can see it's identified Europa, and the one over here is Io, although Io is not visible in this particular frame.
Okay, so thank you.
For planning observations, this particular tool is very helpful because you can run it as an animation to see when the great red spot's going to be visible, when a moon is going to be in a particular place, when there's going to be a shadow transit, etc. So it's very helpful for planning observations as well.
Fantastic.
So up here, you've got gamma and brightness. These you can all pretty much just leave alone. There is this thing called LD compensation. LD stands for limb darkness. And you can see the limbs here are darker than the center of the planet. By clicking this on, you can lighten the limbs somewhat, and that's adjustable with this value right here. I find about 0.20 works nice for Jupiter. I usually turn the limb darkening on. Once you've got the image selected here the way you'd like it, you hit the F2 key or hit save. And it will save that image with an IMS extension. The IMS extension is the timing stamp so that it knows how to align these images when you put them all together. So we're going to save this one. I'm going to hit F7 to bring up the second one. Oops, that's not it. Let me hit F7. Here's our second image. I hit F11 to make sure it's. We didn't hit F11. I hit F11, make sure it looks good. It does. Turn on limb darkening, hit F2 to save it. No, I don't want to, I must have picked the wrong one. In any case, what I'm doing here is picking the three images, making sure that they match up where they should be, and then saving them. And they have nice function keys to do that. So what we've done is I've saved three images with the timing stamps attached, and now we're ready to derotate. Under the Tools menu, we have derotation of images, and we're going to derotate these images because they're already colored because they were taken with a one-shot color camera. If you were using red, green, and blue filters or other filters, you would have to derotate each one of those, in which case you'd use this choice right here, derotate RGB frames. You can actually derotate video frames if you've got forever to sit there and watch your computer. But we're just going to derotate these three images, and what we have to do is load them in. I'll warn you that after you use WinJupos the first time, it will remember what was in there before when you derotated. So you have to be a little careful that you go into edit and you remove any images that are in there from the last time, and then add the new images that you're interested in. So if we go to our subdirectory here, here are our three timing images with the IMS directory, with the IMS timestamp. We select all of them and load them in. And so what WinJupos is going to do is going to derotate these images and create a new picture with the derotated images with north at the top, since I've selected that down here. Now, under the options, you can pick various different things like correcting for the spots created by the moons. Where the moons are not perfectly round, you can have it adjust the pixels around the moon or the pixels around the shadow on the planet by adjusting the size of the, how many pixels you want to use. You can tell it whether you want to shift rotation size, etc. Those are all things that should be turned on. I usually make the picture slightly bigger because it picks just the planet. But I would come over here to the size and put in something larger, like perhaps 700 pixels wide, so that we get Europa in the picture as well. And then you can put your name in here as the observer. So that puts your name in the final image. Once you
Question.
Yes.
Okay, you just showed how it can correct for roundness, circularization, whatever you want to call it.
Yes.
Now, can you, as everybody knows, Jupiter isn't a perfect circle because of the rotation speed. Can you apply that tool only to the moons?
Yeah, that function only applies to the moons or to any shadows on the planet that tend to be made oblong in videos.
Okay, and that they would be oblong because of the fast rotation of Jupiter, basically,
Well,
right?
they'd be oblong because of the angle. For instance, when the moon is just over the limb of Jupiter and the shadow is right behind it, it tends to be oblong because the shadow's over here on the far part of the rotation.
Okay,
But again, the program will try to make the moon as round as possible if it's not so, because of the way it's aligned it in the step that we just did before.
okay, so it's not going to change the Jupiter
No,
because
Jupiter,
it's an oval, basically.
yeah, and that's what we did back in this section here when we
Okay.
applied this oval to it.
All right,
All right. So
very
again,
good.
we're under derotation of images. You can, if there's one image that you want to use as the reference image, you can right click and say, use this as a reference for optimization or for timing. You can do that if one image is better than the others. But in any case, when you put your images in, and I think this is one of the benefits of this, again, what we're hearing is we're stacking multiple images, all of which have been stacked separately from their AVIs before, sharpened separately, and now we're going to derotate and stack those derotated images. So again, you're increasing the signal to noise ratio to a certain extent by stacking these. And typically, I'll use anywhere from 3 to 7 separate images for this step. Once you're ready,
Greg,
yes.
how far apart in time are your images up there at the top?
My images are not very far apart in time at all, because I shoot them one right after the other. Now you can take them further apart in time, but the farther apart they are, the harder WinJupos is going to have, harder time it's going to have to derotate the images to a single image.
Do you have a suggested time maximum?
Well, as I said, I usually shoot anywhere from 3 to 7 AVIs, and that usually takes 4 or 5 minutes.
You do one right after the other.
One right after the other.
Okay.
And sometimes I'll wait a couple hours and come back and then catch Jupiter at a different location with a great red spot visible, or the moon's in a different location. But typically, if I'm going to try to make a single image, I'll take multiple AVIs, process them the way we've gone through here, and then stack them in WinJupos.
So how long is each of your AVIs when you actually shoot them? How many seconds?
30 seconds.
30 seconds, okay.
30 seconds at the focal length that I'm using, which is about 6,000 millimeters. So once you're ready to do it, you hit F12 or compile image, and it does that, and voila, you have the stacked image. Derotated, the moon's aligned as much as possible, and you're ready to go on to the last step. I'm going to go through the last step fairly quickly. You may notice that it may not look quite as sharp here, but remember the last step then is going to be sharpening, and the sharpening that we're going to do is going to be done with any of the sharpening tools that you have at your disposal. I normally use Photoshop. So let me see if I can find Photoshop. Do you see Photoshop?
Well, we did.
You did.
Now we see sunrise.
Let me try again.
Okay.
How about
There
now?
we go. Yeah, it's there.
Okay. So what I normally do in Photoshop is, first of all, I have my toolbars over here with the original image. What I usually do is hit duplicate that image by hitting Control J a couple times. And so now I have 3 duplicates of this, and I'll go ahead and I'll try various different sharpening techniques to each of these images. So for example, for the first one, I might use overlay, and I'm just going to name this overlay so I can remember what I'm doing. For the overlay, I'm going to select a blending mode of overlay, and then I'm going to come over to the filter choices, going down to other, and I'm going to select high pass filter. When I select high pass filter, I'm going to adjust the pixels down to about 3.5 or so. And you can see there some of the detail on Jupiter shows up here. And I click OK. And then using the overlay blending mode, that filter is applied to Jupiter here. And we can see what the effect of that is simply by turning that filter on and off. And I don't know if you can see that at home, but this is with the filter on, and that's with the filter off. So you can see that using the overlay and high pass is one way of creating a sharpened image. The second one I'm going to call unsharp, and we're going to apply an unsharp mask to that. Again, going over to filter, sharpen, unsharp mask. And in this case, I'm going to use a radius of about 2 pixels and maybe bump this up to about 175 or so. And you can see when we apply that, this is the applied and this is the unapplied. And so you can see we got a nice degree of sharpening for Jupiter by using the unsharp mask. And we can compare unsharp mask and overlay simply by clicking the little eyeball icon on and off. The last one I'm going to do is sharpen AI. And for that, I'm going to apply the Topaz Sharpen AI plugin. You probably won't be able to see this because I'm not going to bring it up, but I'm going to apply it real quickly and you'll see the result. And I select one of the presets in Sharpen AI. In this case, I selected the out of focus preset. And it's going to take just a few seconds for that to run. Again, because this is an AI plugin, it runs about as fast as your computer can execute those artificial intelligence instructions.
Oh, you're using what version of Photoshop here?
This is a really old version, version 6. The newer versions of Photoshop all have some of these AI tools built into them.
Okay, so I'm using CS2.
You're really old.
Yeah, well, in my experience with all software packages like this, they just keep adding more and more crap to it. You have to learn.
Yeah, I'm not
So,
sure if the Topaz plugins will work with that old of a version, but you could certainly download the trial version and give it a try.
Sure.
I know that they do work with Photoshop 6, which was discontinued in 2014, I believe.
All right.
And they work with Affinity Photo as well.
I use Corel Draw professionally, and their package is called Photo Paint. So I may give that a whack.
Yeah, the Topaz plugins, you don't have to use Photoshop. They work on a standalone basis as well.
Oh, okay.
You get them both ways. So again, by clicking the little eyeball icon on and off, you can decide, do I like this one, or this one, or this one?
It's like being a optometrist.
Yeah. So I kind of opted for the Sharpen AI is probably the nicest sharpen one. You can also then, once you've decided which of these you like, you can simply flatten the image, discarding those other layers, and then save this under a new name, so you don't overwrite the original, and you have your final image. Of course, you can do other stuff here, like bump up the saturation a little if you think it's not saturated enough, or bump it down a little bit if you think it's a little bit oversaturated. So I'm going to stop there. If there are questions, I'd be happy to try to address them.
Just a comment. Being that a lot of us are the older folk, it's amazing that this kind of work exceeds the images that the Pioneer spacecraft took. And I would say that it's approaching Voyager quality. And also now I see how Damian Peach does his work.
Yeah, what I've showed you tonight is by no stretch of the imagination what I come up with. It's outlined very nicely in Sean Walker's November article, and Sean Walker gave a nice talk on this at one of the AIC conferences a couple of years ago. Basically the same steps, using AutoStacker 3 or 4 to stack the AVI or SER video files, and then using some wavelet sharpening program, followed by WinJupos, especially for Jupiter and Saturn, and then finishing up with Photoshop or GIMP or some other program that's good for final processing of photos.
Greg, have you used AutoStacker 4 yet?
I have not. I went and looked at it, but I haven't used it.
Curious
James?
what, be interesting to get your feedback on that.
Okay, yeah, it's just released in the last couple of weeks, and I think it's still a beta version, and apparently there are still some issues with some of the features. Can everybody see this page with software for planetary image processing?
Yep.
Okay, so I will put this on the TAA forum under the files. If you want to go to any of these web locations to get this information. And I will also try to upload the recording to YouTube, so we'll have a recording of it, so you don't have to try to remember what I said way back in the first 20 minutes. You can pull that up and go through it at your own speed. Any other questions?
Did you say WaveSharp was also free?
Yes. AutoStacker 3 and 4 are free. Registax, you can still get Registax 6. It's free. WaveSharp is free. Photoshop you have to pay for, obviously. Topaz, those are, you can buy those. You used to be able to buy these separately, but now I think you have to buy the whole suite, and it's about $170. You may still be able to buy these individually, but they're about $80 each. If you have to buy just one, I would buy the Denoise AI, because it has sharpening built in as well, and it can do the sharpening just about as well as what I demonstrated to you for Sharpen AI.
Okay, other alternatives to Photoshop if you're really on a budget. I haven't tried it, but I hear of a program called GIMP,
Yeah,
GIMP, which is what you call open source Photoshop emulator.
yeah. GIMP is completely free, open source. It has pretty much all of the functions that I showed you there. I don't know if the Topaz or other plugins like the Russell Croman plugins work with GIMP. I haven't had a chance to try that. I know that they do work with Affinity Photo, and they do work with older versions of Photoshop. Okay, the last thing, if there are any other questions, last thing I wanted to share with you, next month, we'll have Dr. Ed Foley and Doug Summers give a brief presentation on the new 32-inch Cassegrain telescope that TAAA has obtained and is going to be installed at CAC. And they're going to tell us a little bit about that telescope installation, and they're going to give us some hints as to what might be possible in the future for those of us who are interested in imaging. And obviously, anybody who's interested in imaging would probably be interested in imaging through a 32-inch Cassegrain telescope. So that's next month for the December meeting. You may have heard about the 32 already. If you're interested in it, be sure to attend. We're now in the process of fundraising to get the observatory ready for the 32-inch telescope. This is the pledge form. If you're interested in making a donation, you can get the pledge form by going to this big long Dropbox link over here or downloading this. I'll post this also on the TAA forum website tomorrow. So are there any other questions or comments from folks?
Okay, I haven't done any planetary work in probably 15 years. And what I'm going to do is try to use these modern methods on old AVI files that I shot at Mount Wilson Observatory. I used to use a 4-inch Brashear refractor at the 24-inch at Mount Wilson with the TIE program. And I'm anxious to try all these new procedures on Mars images I took during the famous 2003 opposition of Mars.
Yeah, if you have AVIs of those, that'd be a good place to start. Now, be aware, if the AVI was done full frame, the planet is going to be very small, probably, unless you're using extremely high magnification.
I used eyepiece projection.
Okay, but you still may have a lot of dark space around the planet, which is going to slow down the processing. I didn't talk about another program called PIP, P-I-P-P, which allows you to edit videos. And a lot of folks use that for planetary imaging in order to crop down the dark areas around the planet so that when you load it into auto stackered, you're not running auto stackered on a lot of dark background space, just on the planet disk itself. That'll speed up image processing for auto stackered and all the other programs as well. You will have to go up and look up the correct format for saving the files. If you don't use auto stackered, you'll have to make sure that your files have the correct timestamp format in the title so that you can load them into WinJupos. And that's available if you go to the WinJupos website. They explain all that.
I got a question too.
Okay.
Would any of these lend themselves, these programs lend themselves to solar or lunar photography?
Absolutely.
Okay.
You can use auto stackered and any of the wavelet programs for lunar or solar or any of those types of images. In auto stackered, you select a surface rather than planet. It's because you're usually having the entire surface of the moon if you're doing real close-ups or of the sun. If you're doing the entire disk, then you might select planet and let it pick alignment points on whatever's visible on the entire disk.
I was wondering if these would lend themselves, or any of those would lend themselves to total solar eclipse photography.
Yeah, if you have a video, you could use it.
Oh, well, no, I don't. I was wondering, like, say, if it could be used like with a ZWO 2600, it can shoot like several frames per second.
Yeah, you can load as many frames in as you want.
And taking it, as I'm looking for something for the eclipse in April. And, you know, like, for example, you know, so many people are able to stack and get a spectacular image of, get the outer corona as well as the prominences and then, and even the chromosphere, all in one. And it's,
Yeah, I don't think auto stacker would work very well for that because
Okay.
the moon moving across the disk of the sun, it would try to rearrange all that for you, and
Okay.
it probably wouldn't work. But if you're
Okay.
doing just lunar imaging, what I usually do for lunar imaging is put my get the target on the chip, whatever crater or rill, whatever you're looking at, and then I usually set my acquisition software to take like 5,000 frames. Put the mount in lunar tracking, let it take 5,000 frames, and those will all be in a video. And then that can be loaded into AutoStacker. Let it pick the best 1,000 frames or 1,500 frames out of those 5,000, and then stack them and then follow on with the rest of the procedure the way I've outlined it.
I was thinking that could potentially be applied to a total solar eclipse shot. If you're going to stack several that were taken within a couple seconds,
Yes.
like say right at the start of totality, and you got all the prominences out on one, just right after the diamond ring has gone in.
Yeah.
And you've got, and then like I can take maybe this camera can take maybe several, like 3 to 5 frames per second or something, and then maybe take 2 seconds worth and stack them.
Yeah, again, you're going to be limited by how much movement is occurring in the target during that time.
Yeah, but like say if I, like you were talking about on the moon, like say targeting on a crater or something, I target on one of the couple of the prominences, even though the moon itself would probably move, slightly during the time, so that, and then stack that prominence.
Yeah, a lot of solar imagers take images through hydrogen alpha filters and then use AutoStacker to stack those just the way I've described this evening.
Oh, okay.
I don't think it would work very well for the eclipse because the moon is moving quickly enough that you couldn't, take a very long video before you get significant movement in the video that the AutoStacker couldn't handle. And it's the same reason I limit my Jupiter images to 30 seconds.
Right. Okay.
Okay. Other
All right.
questions? All right. Well, thank everybody for your attention, and I hope to see you all again next month on December the 18th.
1 week before Christmas.
Yes.
Just one more comment. Planetary photography, you basically don't need huge amounts of aperture. As a matter of fact, it can work against you.
Okay.
And I'm in a chat box, I'm putting in a picture I took with the 60-inch telescope at Palomar. And as you can see, it doesn't look that good. The plain fact of it is, better Mars images were acquired with 3-inch telescopes. So just a point I'm trying to make.
Yeah, focal length is probably the more important thing, and a long focal length refractor will do a great job. All right, everyone, I'm going to stop the recording and thank you for attending.